Okay, I added a lot of stuff to my pink motor generator. I have 4 relays, solid state MOSFET. The black ones go to 480 volts. The white ones go to 60 volts. I have 2 capacitors, 2 flyback diodes, you'd call them, steering diodes that the flyback coming off the drain of the MOSFETs goes through. And I split them off so one goes to this and one goes to this. So I'm having an alternating cap discharge. This one will fire, and then this one will fire. This one will fire, this one will fire. Whenever one fires, I have it disconnected between the diode and the cap. Whenever a cap fires, it's disconnected, it's decoupled from the diode that's filling it. So the cap is sort of independent, decoupled when it fires. And there's never a time when the flyback is not being collected, because when this is discharged and you disconnect the diode, the other one will be filling up. And when this one discharges, this one will be filling up. So this black relay is the one that power goes through. It's normally closed, but when this white relay discharges, this opens up and decouples it. Okay, and here's how I'm doing it. I have 4 Hall effects. This one and this one are going at a 45-degree angle, and there's a little magnet right there. There it is. And when that goes by, boom, the cap discharges. It goes over here, cap discharges. So twice a revolution, or once a revolution, each cap will discharge. Twice a revolution, you'll get a cap discharge from 2 different caps. These 3 little black magnets here, right in here, they are much wider, obviously, than the little discharge magnet. And that's because I want a lot of off time period, open switch period, where the diode's disconnected from the cap. I want to make sure that the cap discharging is not connected to that diode and is decoupled. And so these magnets trip this Hall effect and this Hall effect over here. So these are straight across, so when this one fires, this is decoupling it. When this fires the capacitor, this decouples it. When this fires the other capacitor, this decouples it. So, and I have the same old 16 magnets where you pulse it, because I have 16 rotor magnets. I made the MOSFETs now. I put them back to back, sources connect and gates connect, and switching occurs between the drain of this one and the drain of this one. It's called bidirectionally connected MOSFETs, and this is how you switch AC with MOSFETs. And I might be doing some coil shorting later on, like right after the motor coil pulse turns off. I was thinking I'm going to short the motor coil, see what happens. Here's a motor coil, and of course there's another motor coil below, and you know, same old thing. There it is, going right between the middle of them. The rotor, very thin rotor, 1.5 millimeters. This is when I take reflective strip, when I take RPM readings from it. So it's about ready to go. I still have full wave bridge rectifiers for the pickup generator coil up here, and another one for the pickup generator coil below. So that's power too, besides what I'm filling the flyback, I'm filling the caps with. So I hope to have this going tomorrow, and here's the two outputs for the cap discharge from the flyback. I'm probably going to combine the full wave bridge rectifiers into the caps also, and so the caps get filled by the pickup generator coils and flyback. So I have a circuit drawing. I'll link it below in the description of how this works. And here it is. Okay, thanks for watching.